3, 2.
Hello everyone. First of all, welcome you to attend today's festival. All of you may know that the SkillsFuture is an initiative or program by Singapore government. And the SkillsFuture will be very useful for those of you as an employee who eventually look for the growth of your knowledge and look for opportunity to sharpen your skill, and also to look for opportunity to secure your job. All right? And the SkillsFuture will also be useful to employer, because for employer you may look for opportunity to enlarge your view in the business world, and to open your mind in the market, and eventually also to grow the knowledge and skill of your workforce inside your company. All right. So secondly, I would like to thank the organizer of this festival for inviting me to deliver this public talk. Today, I would like to share with you my thought and viewpoint about the Industry 5.0, which should be robot integrated manufacturing. And all of you may know that today we are in the era of Industry 4.0. Then it may be good for you to know what should be the future trend after Industry 4.0. The key takeaway from today's talk include 1 prediction and 3 understanding. The prediction is about the next phase of Industry 4.0. So in year 2018, so we have already done the prediction about the Industry 5.0, which should be robot integrated manufacturing. Right? Then the 3 understanding include: number 1, the understanding of the nature of a robot and the robotics. And number 2 is to understand the nature of manufacturing. So actually manufacturing includes 3 types of manufacturing, which are mechanical manufacturing, chemical manufacturing, and biological manufacturing. It is very interesting for you to know that the understanding of biological manufacturing will help you to understand the nature of evolution, because today there's a debate about the bottom-up evolution and the top-down design, etc. Right? The number 3 understanding is for you to know the trend in industry, from Industry 1.0 all the way to today's Industry 4.0. Then what will be the next phase of industry in future? All right? So before I enter today's talk, I give you a short introduction about myself. So my name is Qian Min. I'm from Nanyang Technological University. So I did my master and the PhD degree in France under the government scholarship from the Chinese government. I joined NTU in 1993, and I reached the rank of associate professor in 1999. In year 2004, I have published this textbook about the robotics, and last year we have published this textbook about the artificial intelligence. In year 2004, we have launched the International Journal of Humanoid Robotics together with other 2 called Editor-in-Chief. Around the year 2008, we have invented this large-scale humanoid robot in Singapore. All right? And my research focus is centered around these 2 keywords. The first one is intelligence, and the second one is motion. All right? So inside the inner ring, you will see the topics which indicate my interest of doing basic research. Then the topic inside the middle ring indicate my interest of doing applied research. Then the area inside the outer ring basically indicate my interest of doing product innovation. All right? Okay, so now let's start today's talk. So in today's public talk, basically I will just help you to understand the basics about robotics and also to help you to understand the accurate introduction to manufacturing. Because by default, when we talk about the manufacturing, all of you may think about the mechanical manufacturing, and we largely overlook chemical manufacturing and biological manufacturing. All right. Then the key focus is to convince you what should be the next phase in manufacturing. The next phase in manufacturing should be robot integrated manufacturing. All right. So let me start with a short introduction about the robotics. So actually, in order to understand robotics, you need to spend at least one semester in the university. So then within 10 to 15 minutes, I try to give you a rough idea about what is robot, what is robotics. All right. Okay, if you look at this slide, immediately you understand. All right. So we, among the other animals, are the most advanced creature of the nature or universe. All right. And here there is an interesting debate. All right, about the question of what is the driving force behind the invention or creation of these advanced creature on Earth or in the universe. All right. So there are two theories. One is bottom-up evolution, and the second one is top-down design. Hopefully, after today's talk, you will be more or less convinced by this theory. All right. So later I will tell you why. Okay. And then you may want to know, okay, what should be the most advanced creature by human being? Because the nature create human being and all the animal or all the life, all right, in the universe. Then what should be the greatest creature by human being? I guess the answer should be robot. For example, in terms of humanoid robot, they are at least about 40 degrees of freedom. Okay, so in terms of complexity of motion, robot should be more complex than aircraft, than vehicle, or than the boat, etc. Right? So it's quite easier for you to understand. Okay, this conclusion. Then there's a public worry about the replacement of human labor by robot power, or this is a general worry from the public. Then, okay, we may discuss about the intention for us to invent machine, and in particular, what is the invention or intention for us to invent robot in order to free human being from doing dangerous, dirty, or difficult job, etc. Right? So, if you understand the true nature of manufacturing, then you should not be worried about the displacement of the job in the industry, because manufacturing includes design, production, and the marketing and the sales. All right. So we can free human being from doing dangerous, dirty, difficult job in production. However, then we can let human being to enjoy, okay, activity in doing design, in doing marketing, in doing sales, etc. All right. So you should not have this worry about the displacement of job in industry by the deployment of robot. All right. So then this slide basically gives you the answer behind the intention of deploying robot in industry. Okay. The number one motivation basically is to free human being from doing this 3D type of job. Okay. Firstly, refer to difficult job. Secondly, refer to dirty job, and thirdly, refer to dangerous job, etc. Right? And the second motivation should be in future. Eventually, we can leverage on the use of a robot to extend our mental capability. For example, in the educational sector, and in future, maybe every student may have a robot tutor. Then in this way, hopefully, we can shorten the learning curve and learning cycle. Right? So it is a good thing for us to leverage on the use of robot. Right? And since robot has so much benefit in industry and the society, then you may want to know, okay, how to invent a robot, right? Then what is a robot? What is robotics? How to invent the robot? So I will start with the history of inventing robot in China, in Western country, in Japan, and eventually in Singapore. All right. Once you look at the history, more or less you know what is a robot, what is robotics about, etc. All right. So if we believe that the teleoperated robot arm manipulator is part of the robot family, then immediately you will agree, actually, the history of robotics was studied in China because the first generation of a teleoperated robot was invented in China under the name of pupper or shadow pupper. Alright, so here you see some animation. Alright, so this is quite interesting for you to know. Then what is a shadow pupper? So I just play this short video for those of you if you do not know what is a shadow pupper. Because we do not have enough time, we just stop here. So, this video gives you another idea about the creation of a new job with the deployment of the robot. For example, here we make use of a robot to create additional entertainment. Alright? So eventually, how to create a story? The human being can create a story. So automatically you may think about the creation of a job by the deployment of these kinds of robot, right? So actually the major contribution in robotics come from a Western country, all right? For example, the terminology robot was born in year 1921 in Europe. The terminology robotics was born in year 1941 in Europe, okay? And then in year 1942, a Russian writer has formulated the 3 rules which will guide the development of the robot. And the second generation of a teleoperated robot was invented by General Electric, which is a US company. And the first company in robotics was set up in USA in year 1956, all right? And today, I guess some of you may know that the most advanced humanoid robot, which is developed by Boston Dynamics. This is a US-based company, all right? And then this short video just highlight to you the history of inventing robot by a single company in USA. Okay, so this should be good enough. Then we move on. But interestingly, in Asia, okay, or in the whole world, there's a special country, which is Japan. All right. So after Second World War, Japanese company has put in tremendous investment into the development of robot and the robotic technology. And you will see the history of inventing robot in Japan. Actually, it's an extension of history of inventing robot in China, because they also start with the use of puppet, right? Then they continue this tradition. And today you see this Honda company's Azimo. Okay, this is also one of the most advanced humanoid robot in the world. All right, so that gives you idea, okay, about the history of inventing robot by a single company. And then this slide basically showing you different generation of robot which were invented by a single company in Japan. And then this slide basically showing you some video, okay, of demonstration by Honda's Azimo humanoid robot. Then from these 4 videos, at least you will see that in terms of the skill, more or less robot could reach human level or human-like skill. you may want to know, okay, what is the history of inventing robot in Singapore, all right? So in NTU, we have set up a robotic research center in year 1994, all right? So then around the year 1996, we start to develop humanoid robot, and around the year 2008, we have developed this full-size humanoid robot, and also we have reduced the size of the humanoid robot, okay, all the way to a size which is similar to a handheld handphone, all right? Then you see this is a minister inside the Singapore's government, and this Android developed in NTU, and in the company we see there are company inventing cleaning robot, inventing patrol robot, security robot, or inventing the e-commerce robot for the delivery of foods. And this is a robot in the hospital environment, etc. So you see, Singapore government has also invested a lot into the development or invention of robot in Singapore, right? So then this video shows some demonstration with our humanoid robot. So here basically give you an idea about the human-robot interaction at the signal level and also at the cognitive level. So this one is at the cognitive level. Let me just through the conversational dialogue with the use of language, we can instruct a robot to perform a task. Then this is the interaction based on the use of signal, okay, which is the force talk. That is the interaction based on use of signal, which is the visual signal, right? Then this video basically showing you the level of intelligence reached by today's robot, okay? So here the robot is doing autonomous hand-eye coordination, all right? So there's no intervention of a human being, all right? So robot measure the geometry of the object to be grasped, okay? They use that information to plan the arms motion, fingers motion, then execute the motion, all right? So it's fully autonomous. So at least you will see today's robot has already reached a certain level of intelligence or autonomy, right? So I move on. So then based on the knowledge and that I showing you in the previous slide, then immediately you understand, okay, what should be the new definition of a robot. Because traditionally, definition robot refers to the definition of an industrial robot, okay? For industrial robot, people just talk about the reprogrammable machine, which can carry different kinds of tool in order to perform different kinds of task or action, etc., right? Now, we must consider robot as an embodiment of a body, brain, and the mind, because there's a lot of interest to develop intelligent robot, all right? So AI could play a major part in the invention or design of the robot. So therefore, so the key concept or component inside the definition of a robot must include these three items. First is to execute motion. Second one is to perform a task. All right. So for industrial robot, they include these two items. So this is the additional one: interaction with the people. Because in future, we want the robot to be able to work together with a human being. So therefore, interaction with a human being is extremely important. And here, interaction is at the cognitive level. Because to interact with a machine, with a robot at the signal level is quite easier. You can use a touch screen, use a keyboard, or use a gesture, whatever, right? But what we want to reach is this one. Cognitive level means what? Through the use of human language. So we must let the robot to speak our language instead for a human being to learn machine's language. And from this slide also, you know the opportunity for us to create new job, all right? So in future, in the company, eventually we may have a lot of control room. We deploy robot inside the production line. Then the human worker can sit inside the control room, then tell the robot what to do. So this gives you another idea about the new job creation with the deployment of a robot, right? So this is why you should not worry about the deployment of a robot in the industry, and you should not worry about the loss of the job, all right? So we can free human being from doing certain type of job, then create new type of job for human being to enjoy. All right. So that's about the robot and robotics. Then we move on to look at the nature of manufacturing, because this is very important. All right. And first, we want to know why manufacturing is so important in the economy. To a certain extent, we can say manufacturing should be the major pillar of the economy. All right. So why is this so? Actually, the answer is very simple. Manufacturing creates a value, and then we overlook the definition of the value. What is the value? Because if you ask your friend, maybe they say, it's quite easier to answer this question. Actually, it's not. All right. So precisely speaking, okay, value equal to the result plus exchange. So it means what? Value equal to exchangeable and the useful result. If you have a result you cannot exchange, there's no value. It's like you have a company produce 1 million of a vehicle. If you cannot sell them, then it's a total waste. All right. So this should be the #1 rule in economy. All right. So manufacturing creates a value. All right. Why so? Because manufacturing creates a result. Manufacturing includes marketing and the sales. All right. So you must keep this view in mind. All right. Then what is exchange? Exchange basically means you must have a seller, you have a buyer. Then who are the seller? Basically is what? Is the owner of a company, owner of a production line. All right. So without the manufacturing, there's no seller because you have nothing to sell. Right. Then the buyer should be the consumer. Right. Then our focus should be how to create the result, how to achieve exchange. So create the result. Answer is what? Manufacturing. How to create? We can use labor to create, human power to create, then machine power to create the result, or robot power to create the result. Then how to achieve exchange? I just quickly go through the scenario of exchange just for you to understand. Okay, this also play quite important role. Okay, in order to sustain a good ecosystem for manufacturing. So without manufacturing, there will be no market, and we know there are 3 major markets. All right, in economy we have a market of the product, market of the manpower, and also pay attention to the market of the finance. And if you look at the history of human society, and a lot of trouble come from here. You can start to answer this question. How come a lot of trouble come from here? Every 10 years, there's a financial crisis or economic crisis, all right, worldwide, all right? I guess it's people do not pay attention about the exchange, and in particular, people do not pay attention to this one. So actually, there are 4 types of exchange. We can directly exchange result with result, or exchange result with a currency. This is a sales journal. Or exchange currency with the result. This is a purchase. So you sell your product, you buy things, okay, buy the product, then you use your product to exchange with other people's product. This is what? Just to exchange money with money. But this one does not create value. So you will see, so we must encourage these first 3 types of exchange. We must control tightly the 4th type of exchange. And actually, is this one create periodic crisis in the world every 10 years. So we suffer this one. So I guess the government official must pay attention to this one, must strongly control this one. Because the forced exchange never create any value, right? Then you may want to know what is the manufacturing. So roughly you know that manufacturing is to create result, and also is to sustain exchange, all right? So if we want you to give us the accurate definition of manufacturing, I guess a lot of people will confuse between manufacturing and the production. Manufacturing is not equal to the production, all right? And in layman terms, there's a frequent confusion. So I just play this video, then you can try to think about the answer. Okay, what should be the accurate answer to this question? What is manufacturing? Right? From here you see we make use of a machine, automated machine, to produce result. But when we talk about the manufacturing lab, we never show the marketing, sales, exchange. So remember, value equal to result plus exchange. Because without the exchange, the result is no use, right? But when we talk about manufacturing, in our mind, we always think about the way how to produce result, right? And in today's situation, the crisis in the worldwide economy does not come from production. I believe it's come from marketing and sales. So there's too much exchange between currency to currency, right? Okay, so this just give you a rough idea about the scenario in the production line, all right? So interestingly, we can trace the answer to this question back to maybe a few hundred years BC. So then Lao Tzu, I guess for those of you, if you know the history of Chinese culture, then you know, okay, this person, all right? So basically he has already given us the answer. So he said, basically the answer to this question is 1 produce 2, 2 produce 3, 3 produce all. All right, so it's very, very abstract. Then how to make today's people to understand this answer. So here I help you to understand. All right, 1 produce 2 means among all the factor or cost, we can divide them into 2 types. One is the inner cost, another is the outer cost. All right, so inner cost means it's the inner law. Outer cost means the outer condition. All right, then with these 2 types of factor or causes, eventually we can produce 3 types of changes, all right? So we have a quantitative change, qualitative change, and fictional change, all right? Then combination of these 3 types of change produce all the things in the universe on Earth, right? So lucky for you, actually is very comprehensive, accurate answer to this question, all right? So based on that answer, immediately you understand manufacturing includes these 3 types, right? Quantitative change means what? Mechanical manufacturing. Qualitative change means what? Chemical manufacturing, all right? And fictional change means what? Biological manufacturing, all right? Then immediately we can formulate, okay, the answer or engineering answer to this question, what is manufacturing? So manufacturing is a system which takes a product and join and the material as an input, then we transform input into the output. The output could be the finished part or integrated product, right? So you have an input, you have an output, so this is a system, right? The only difference is biological manufacturing takes a long time. Immediately you understand why people come out of this theory of evolution. And we know when we do manufacturing, quality control is very important. What is quality? Quality means what? Is a 1 over deviation from design specification. And since this is a long process, it can take months, years, all right? So then it's very easier for us to see the defective product, all right? That makes people to believe that the human beings are the evolution of the monkey, all right? But if you know this one, actually should be reversed. Monkey are evolution of a human being because we are the perfect product and the monkey are the defective product of human being, right? So you can immediately understand the conclusion, okay? It's just for you to understand, all right? Then in Chinese language translation, manufacturing means to produce and to create. So then immediately understand manufacturing include design. To create means what? Mentally to create the join, all right? So here it says mentally to design, and then to produce means what? To manually make, all right? So manufacturing include design and production, and also the marketing and the sales, all right? So then this slide gives you an example for you to help you to understand the landscape of manufacturing, okay? So we have an idea in mind. Let's say we want to mass produce a machine which can fly from one location to another location. Then we must start with the design, all right? Once we have all the join of the part join, then we can enter the phase of production. Once we get all the key component, key part together, then we can start to do the assembly. Then we have a finished part. That will trigger marketing and the sales. Right? So the manufacturing include design, production, marketing, and the sales. This is another example. If let's say we want to have a robot which could be deployed in the home environment, right? Then we must start with the design, followed by the production, then followed by the marketing and the sales. All right. So that gives you a very accurate answer. And then what should be the detail or the blueprint of the manufacturing? So this slide basically gives you a whole picture about the manufacturing, which is related to any company. All right. If you understand this slide, basically you understand the theory of manufacturing. And from here you can identify these three phases. Design. From here, designs belong to virtual manufacturing. We can talk about design of product, design of process, design of a production line, design of a supply chain, etc. All right. Then we have the production. So inside the production, basically we have a series of process for us to transform input to the output. Input come from the inbound logistic, then output will be sell, distribute to the consumer, to the customer. All right. Then behind the production line, then you will see today we make use of a lot of equipment. All right. Then we can talk about automation, talk about the control, etc. And since this is such a so complicated system, this is much more complicated than a computer. So inside the computer, we talk about the operating system. Then we can also talk about the operating system of a factory. Then what is operating system of a factory? We do not use OS, we use MES, Manufacturing Execution System. So actually this is just operating system of the factory. So it's quite interesting. You can do a comparison between the computer and the factory. All right? So you can identify similar things there. All right? But how to visualize this blueprint, and this slide help you to understand slightly better, okay, the previous blueprint. So from here, you see we have a design, then we have a production, then we have marketing and the sales, all right? And the manufacturing is a system. The system has an input, has an output, okay? So this will help you to visualize, okay, what is the landscape of a manufacturing. Once we zoom into production line, then you will see there are a lot of systems inside, and all these systems will be an automated system. The inside automated system, you will see control loop, and inside the control loop, you will see the presence of a sensing control automation. All right. So immediately you understand, okay, how is a control automation are related to manufacturing in today's situation. All right. Okay. And then subsequently, I just showing you, okay, some scenario of doing manufacturing, and this may correspond to industry 1.0. At that time, there's no automatic control system. All right, so all the machines are being manually operated. Once we reach industrial 1.0, so it means we make use of mechanical power on top of human power. All right, and with the invention of a steam engine and the first adoption of a mechanical power is a textile industry, right? So that triggered the Industrial Revolution 1.0, all right? Then subsequently, we can mass produce identical product. Then we have this concept of a production line, all right? Then after that, then we invent advanced machine, because this is the soldering tool, right? To join two workpieces together. Now, this gives you an idea about the invention of the tool, then invention of the machine. So then we use the machine to transform input material into output material. So this is the input material at a certain geometry, then this is the output material at a new geometry. So this is the input material at the initial geometry, output material at the new geometry. So you see the transformation of a material from the input to the output. Then today we use advanced machine, all right? So from here you will see we can combine a robot, this is industrial robot, together with a computer, control the machine. So let them work together in order to achieve a full autonomy, etc. Right? And from the photo or image that I'm showing you, then you see there's an evolution from industrial 1.0 all the way to 4.0, then eventually to 5.0, right? Then you may want to know, okay, what is the history of manufacturing, or how is the history of manufacturing looks like. So this is just a short video, okay, give you an idea. So start from manufacturing, which heavily depends on the human power, to the manufacturing, which make use of a robot power. Okay, it should be good enough. Okay, then, okay, all of you may know that today we are in the era of industry 4.0, right? Then how is the history of manufacturing looks like? Then you'll see the first evolution was triggered by the introduction of mechanical power. The second revolution was triggered by the introduction of electric power. Then the third revolution in industry was triggered by the introduction of computing power, right? Because for industry 3.0, we call it as a CIM, computer integrated manufacturing. Then for the fourth revolution in industry, it is triggered, okay, by the introduction of networking power. Because for industry 4.0, we make use of a network, right? So to synchronize all the operation, etc. And here is one more version of history of manufacturing. Okay, so again, so you see this okay, introduction of new technology and the use of a new type of power. So all these are the classification from the viewpoint of technology, use of energy, etc. Right? So I use this slide to help you to better understand the history of manufacturing. So from the viewpoint of energy, so it's easier for you to understand this history, okay? So revolution 1.0, introduction mechanical power. Then revolution 2.0, introduction of electric power. Revolution 3.0, introduction of computing power. And industry 4.0 was triggered by the introduction of networking power. Then from this trend, immediately you will see what should be the 5.0. 5.0 is what? Robot power. Alright, make use of a robot power to achieve. Okay, then here's some example, okay, how to make use of a manpower, human power to produce a result. Then use electric power to produce result, use computing power to produce result, and the leverage on the networking capability to produce result. Then today we already see some major company which has already adopted the use of robot power, right? We can also look at the history of the manufacturing from the viewpoint of the control, right? So then you will see for industrial 1.0 is a manual control, human control, because there's no brain, right? Then start from 2.0, we use feedback control, then we have an analog controller. Then 3.0, we have a digital controller, that is a digital controller, microcontroller. Then today, we use network to control entire factory, etc. Then future, we may leverage on the use of a robot to achieve the control of manufacturing. All right. So that gives you a quick overview about the manufacturing. And so the previous slide basically already showing you the trend from academic point of view in terms of technology, in terms of use of new type of power. All right. So now we move on to see, okay, what will be the next phase in industry, all right? So our prediction is robot integrated manufacturing, and I will just play this video in order to convince you, okay? from this video, you already see that the robot integrated manufacturing is already a reality. It's not the science fiction, right? So some major company have already adopted this solution. Okay. I believe this video should be able to convince policymakers like in Singapore to venture into Industry 5.0. Because we are a small nation, we do not have a very large population. However, we can have a large population of robots, so it's not the issue. Right? And we can set up a production line like this. Why not to produce the major consumer product like the vehicle, handphone, TV, etc. Right? So you see, okay, robot integrated manufacturing is not a science fiction; it's more or less a reality. Then, okay, from academic point of view, we are confident about this evolution. Then, how's about the viewpoint from investor, viewpoint from a consumer? Okay, will the investor, consumer accept this trend? All right. So the answer is yes. All right. So in the consumer market, so you will see there's a demand from the consumer. Okay, consumer always look for product which should be smart, which should be network centric, which should be energy efficient, which should be compact. Compact means small, which should be environment friendly. So this is a demand from consumer. So therefore, we need to upgrade okay, the manufacturing in order to meet this demand from the consumer. So this is one reason. And the second reason is to, from the investor point of view or the shareholder of the company point of view, they will always try to maximize the profit, minimize the waste, or minimize the cost. So therefore, they always look for new type of energy, new type of control in order to achieve efficiency, okay, reduce the cost, all right? So then from energy point of view, you will see, all right, there's a trend there. From control point of view, there's also trend there, all right? So all these trends converge to Industrial 5.0, which should be robot integrated manufacturing, all right? And then this is the demand from both sides. From the investor point of view, we like to do mass production. Then from consumer point of view, we want to have customization, personality. Okay, we do not want everyone to drive the same car, have the same handphone, same TV, whatever, right? To have this flexibility of personalized product, customized product. Then how to accommodate these two conflicting demands, one from the investor or owner of the company, and the one from the buyer, the consumer, right? The only solution is one, to upgrade the manufacturing and move into robot integrated manufacturing, because with robot, at any point of time, it's easier for you to change the program, right? So in the same production line, it's not necessary for you to produce the same vehicle. Eventually, to a certain extent, maybe the production line could produce a car, could produce TV, could produce other type of product, okay? Academically, it's possible because for a robot, it's very easy to change the program. Okay, because a robot is a universal machine. You just change the program, then you know how to change the task, right? So now I'm going to show you, okay, so actually in terms of technology, we are ready to move into Industry 5.0. For example, we have automation technology. Inside the automation, basically we have a feedback control loop, all right? So we have a control theory, which supports this transition. And then eventually we have an intelligent controller, which will support this transition also, right? So we have a sensor, advanced sensing capability to implement intelligent control system. And in particular, today, robotics technology has already reached a certain level of maturity. So if you understand this slide, basically you understand robotics. All right, this will help you to understand what is robotics. Okay, so input to the robot is a task. Task could be any task. All right. Then inside we have a module to decompose the task into the motion in task space. Then apply kinematics. In kinematics, we can describe motion in joint space. And then the output from here will be the input to the inner feedback control loop. Then control the motion will be produced by the body of the robot. Then in this way, robot could carry all kinds of tasks. All right. So therefore, since technology are ready, there is a demand from the investor, demand from the consumer. Then I believe we are ready to move into Industry 5.0. All right. So with the Industry 5.0, then we can accommodate the conflicting demand between quantity and personalization, and also with the deployment of a robot, we can free human beings from doing 3D type of a job. Therefore, we have more time to enjoy our living, education, entertainment, traveling, etc. Right? And also, with the deployment of a robot, we are able to create new type of a job. For example, future robot may need to have a service provider, and the future robot may need to have a human teacher to teach the robot to have a new skill or to perform certain new tasks, etc. And for certain human being, we may just want to work as an employer of a robot instead of an employer of a human being, right? So these are the opportunity for you to create a new job, right? And then, since I'm running out of time, okay, so to use a robot to do a pick place is not the issue, right? And to do the sorting, okay, and then to do the welding, okay, so it's not to do the painting, okay, and to do material handling, heavy one, pick and place, and to do the inspection with a complex motion, right? And to carry heavy object, okay? So this is a typical job, right, for human beings to do, right? And we also have implement industrial project which free human beings from doing this dirty, dangerous work. Okay, this is the manufacturing of a ceramic-like utensil, right? So this is a very hot environment. The temperature here could be 200 degrees, and it's a powder. So it's very warm, harmful to the body, to human being. And after 6 months, nobody want to work in such an industry. So then we help them to fully automate the production line. And then this video basically roughly showing you I just play a little bit. Okay, so input is a powder, you see. So this is a dual arm robot. So you see we have a two cavity. This two cavity is to produce a two dish plate. You see a lot of powder there. Then this machine basically is to warm up the powder, then transform the powder into liquid into solid. Then it's the warm up, then cool it down. Alright? So then you see this is a very hot environment. Right? For the display, you see different pattern or the colorful sense. You see this way. So we paint all these color drawing on the special material. Okay. Then through the same process to incorporate the painting into the surface of the display. Right. So this is a warm and a hot environment. Okay. So I just move on. Then this is another video which showing you that the robot integrated manufacturing has already been adopted by automobile industry, right? So this is a video from a Mercedes-Benz company. I just play a little bit. is a dangerous job, welding. Cannot fast. Okay, so this gives you a better view about the space you wish to see. There's a massive deployment of a robot, so it should be good enough for you to have an idea of the deployment of a robot in a factory. Okay, so so that's all for my today's talk. Okay, so this slide basically summarizes what you have learned from today's talk. Okay, so one prediction. The prediction is about the Industry 5.0. Okay, we should be robot integrated manufacturing. I hope by now you more or less have a rough idea about what is robot, what is robotics. All right, and by now you should have a very accurate understanding about the nature of manufacturing. In particular, okay, these are three types of manufacturing. And then lastly, I guess more or less you will be convinced about the future trend in manufacturing. From an academic point of view, from the investor point of view, from a consumer's point of view. All right? And the additional understanding is for you to know what is the nature of the evolution. All right? So evolution actually is a concept of biological manufacturing. All right? Thank you for your attention. And now I'm ready to take a few questions. Yes. Thank you. Any question or confusion? No. We just have a few minutes left. Yeah.
How do you see the evolution of robot in the field of education, for example?
Okay. So today's robots are very skillful. Then we are doing research, move toward the direction of making robot as intelligent as a human being. But there's still a long way to go. And in particular, we need to overcome two major issues in science technology. One is human brain is a brain like a computer. Human brain like a computer. This is one area we need to make a breakthrough. And the second one is about AI, or human-like mind. And today, why the program is not synchronized, because you see the development in terms of skill is very fast, all right? Within about 30 years, we are able to control all kinds of motion, all right? But you look at the evolution in computer, and also in the operating system, it's very slow. And today, a lot of discussion about deep learning. A lot of resources invest into deep learning, all right? So, because I have another keynote speech talk about this issue, that is wrong direction, right? So when you talk about the robot intelligence, you must do a comparison between human intelligence and the robot intelligence, all right? When you study machine learning, you must do a comparison between human learning and the machine learning. Look at the human being we spend, for those of you PhD degree holder, at least 20 years, PhD degree holder. at least more than 10 years. Okay, we spend so long to study, to learn, to accumulate to grow our knowledge. Then machine must do the same way, you know. So, but today you see a lot of research on machine learning are based on the study of tuning of internal parameter. So tuning has nothing to do with learning, right? I use a neural network, then tune the parameter, okay? So we need to make a breakthrough, okay? The human-like mind, human-like brain, all right? But more or less is there, but we must invest more.
Do you think the cost of designing and manufacturing robots would decline significantly in the future?
Yeah, so because design is more enjoyable, because we can design human-like robot or flying robot, swimming robot, then based on the specific requirement, you may have a customized version of a robot, okay? So this is why we can let more people to focus on the design work, or if they like to do the marketing, sales, or after sales service, right? So I believe yes, and especially you look at the human brain. Okay, to design the mechanism, but if you look at the design of the actuator, sensor mechanism, this should be relatively simpler. But look at our brain. Our brain is a massive network of CPU. It's very, very complicated. And because our brain has a small size, if let's say we don't care about the size, like the whole building serves as a brain is easier, very big, right? How to squeeze it in such a small dimension, that is a challenge. And also design of a human-like mind, software design is also you still need a lot of improvement. Just look at the programming language. We have 1,000 over. 1,000 over programming language means what? We do not have a best one. Eventually, I believe it should be one or two. It's like today, we more or less we speak English. With the English, we are able to travel everywhere, right? But look at the programming language. There are so many. Right? So yes, so design software, design of human brain like a computer, design human like a body, right? So it's quite interesting. Any question? If not, then thank you for listening to my talk, because then we need to move on to the next talk, all right? Okay, thank you.
要 pause 吗？不要 pause 啊？可以 pause 啊，但是我抛。